All right, well, welcome everybody, and welcome to this month's A3D3 seminar. So today we have a slightly different topic than usual. We have John Reifschneider, who's Executive Director of Duke's Artificial Intelligence for Product Innovation Masters for the Product Innovations Masters Program, and he teaches in this. And just some history about John. He spent 15 years working for companies and in management roles for data services, and he has a Master's of Engineering Management from Duke, and MS in Analytics from Georgia Tech, and a global MBA from EBS in Germany, and he's lived in a number of countries. And he's going to tell us about some interesting software called Qubit that I heard about from him, which sounds pretty interesting. Take it away, John. Probably also talk about more broader things than that as well. So please go ahead.
Sure, thanks, Kate. And by the way, Qubit has nothing to do with the Qubit you may all be familiar with. Completely kind of different topic, same name though. Thanks for the introduction. Nice to see everybody on here, and thanks for joining this afternoon. As Kate mentioned, I lead our AI Masters of Engineering program here at Duke. I joined the faculty about 5 years ago after spending 15 years in industry. So it's very much an atypical path to sort of what I do today. Prior to joining the faculty at Duke, I was running groups in industry that built predictive analytics and machine learning products for a variety of industries, such as electric utilities, transportation agencies, many of the major airlines, et cetera. The program I run at Duke is a fairly new program. It's a professional master's program, so we're really not a research-oriented master's program. We very much cater towards folks that intend to go into industry. About half of our students are actually coming back to school, which is a bit of a unique thing for an engineering school. They go and they work for a couple of years in their field, and then they come back and they study AI machine learning with us, and then they kind of go back into their field after that to specialize in that area. We are an AI machine learning focused program, but by design, from when our program was set up, we cater to a very broad group of students. And so we look for students to come from a variety of different backgrounds, not only kind of the traditional computer science path, but very diverse fields of science and engineering, and want to learn about AI, ML, so that they can then go use those tools in their own field. And when we first set the program up 5 years ago, this was maybe not kind of an obvious thing that AI or ML would sort of be finding use in all these different areas. And today I think that's very much obvious. So we were maybe a little bit ahead of the curve in our thinking there, but it's been fortunate, and we're very proud of the diversity of different types of students that we attract, and also the places we tend to send them after they graduate. We have a large number of students that go into industries like healthcare, for example, pharma, energy, education, et cetera, which is exactly what the program was set up to do. In addition to running our master's program, I run a small applied research lab at Duke that's called CREATE, which stands for the Center for Research and Engineering of AI Technology and Education. Thus, we just go with CREATE. And this is a relatively new lab. So it was set up, we launched about a year ago. It's an internally funded effort at Duke that's really jointly supported between our Pratt School of Engineering and what we call Duke Learning Innovation, which is the pedagogy focused organization within Duke that supports all of our faculty and learners across the university, and also manages all of our online education, et cetera. And so the original vision for setting up the center was to explore the opportunities that were being created to use AI in teaching and learning, with the idea being to treat Duke as sort of a living laboratory where we would build our own tools, pilot those tools within the educational setting at Duke, uh, learn from that, and then potentially disseminate the information and or the tools more broadly beyond the borders of Duke. So that was the original intent of the center. We have currently 9 members in the center. We tend to have a heavy concentration of both master's and undergraduate students working with us in the center. And when we first set the center up, there were kind of 3 main objectives that were part of our mission. And again, maybe a lot of this may look quite a bit different from the types of research labs that you all run at your home universities. It's a bit of a different type of a lab. The first part of our mission was to provide hands-on learning opportunities for our students in building software and working hands-on with AI. And to do that within sort of the educational setting, which is something that by nature of being students there at Duke, they know something about. We have a tremendous interest and demand from our students in getting kind of real world or close to real world experience in building software and working with AI models. And we really didn't have a huge number of opportunities across the university available to our students to do that. So one part of our mission was to create more opportunities for students to get hands-on, get sort of close to industry experience in building software. Secondly was to create tools that would have some value for teaching and or learning at Duke. Things that would actually be useful in our classes, would help improve the learning experience at Duke, possibly the teaching quality within the engineering school and the other schools across Duke. And then number 3 was to study what we learned by implementing these tools in pilots throughout the Duke community, and then disseminate the findings of what we learn, the good and the bad of the impacts of these tools. Being housed within the university setting as opposed to, let's say, at one of the many ed tech companies doing things with AI is certainly an advantage for us in that we really have kind of no skin in the game in terms of positive or negative outcomes. So we really take a completely neutral view of what impacts these tools are having in the educational setting, and not necessarily sort of trying to promote any particular tool. So those were the 3 parts of our mission when we were set up. We are kind of generally focused in 3 different areas. We tend to run multiple projects at the same time. I'll talk in just a moment about sort of our process for how we do that. But the 3 broad areas that we are focusing on right now in terms of development of tools are these. The first one is building tools that can help navigate the educational experience at Duke. So Duke, like most major universities, has a lot of different classes, many of them on kind of more or less similar topics spread throughout the various schools. And it can be challenging sometimes for our students to figure out what classes they should be taking, particularly when they have electives open to them and opportunities to take things outside of their home programs. There's almost an overwhelming number of options available. And the way our course registration system works, there's really kind of a class title, and then there's about 2 or 3 sentences max describing what each course it covers. And so that's a very small amount of money to make a very small amount of information to make a very high stakes financial decision when you consider the cost of your average course at Duke. It can be a challenging decision for students to make. And so we wanted to use AI to help assist our students in better planning and better understanding what opportunities might be the best fit for them, given everything available to them across the Duke ecosystem. Secondly, we're focused on personalized learner support, and within kind of the commercial ed tech space, this really tends to be kind of the main focus with things like AI tutors and that sort of thing. We also think there's opportunity in this space, but there's good and bad there. And so we're actively building different types of tools and looking at the impacts that those tools are having on the learning experience in different domain areas. And then the third area is formative assessment. So looking at how we can use AI-based tools to increase the frequency of formative assessment and also increase the value of those assessments for the learners who are going through the assessments through things like personalized feedback. Okay, a bit about our process. So again, may look quite different than your normal research process by design. We tend to think of it as really a product development process, maybe more so than a pure research process. And so when we set out to explore a new area, that typically involves building some sort of tool, software plus AI in some way, but developing some tool and then putting it into use within the educational setting, and then looking what happens and evaluating the impacts of what happens when we introduce the tool. So our process starts with, we start with sort of a vision of generally a problem that we want to go try to solve. We then conduct what we call stakeholder interviews, which generally means that we'll go out and we'll interview a large number of faculty, a large number of students who are in that particular domain area to understand some of the challenges that they're facing and discuss some of the ways that we might be able to help with those. We then distill what we learned from all of those interviews into what we call a product requirements document. So this is sort of a guiding document which lays out a bit more of the how part of the solution. So what we are going to build in order to solve the problem that we've identified. We then build our first step in actually developing anything is to build what's called a minimum viable product, or MVP. Again, kind of an industry term that some folks may be familiar with, but this is effectively kind of the simplest possible thing that solves the problem that we're trying to solve. So our kind of general philosophy is that simpler is better. And so we try to build the simplest possible version of what we're trying to build first. And then we introduce it into the quote unquote real world setting of students learning and instructors teaching at Duke. And we have them use it and we get their feedback on it, good and bad. And then we go through kind of this iterative process of enhancing and sometimes completely redoing the tool based on the feedback that we're getting from these early stakeholders, these students and faculty that are using the tool in their courses. And then once we feel like we've gotten the tool to the point of being actually useful, we will then conduct more structured pilot deployments of the tools typically within classes, sometimes outside of classes and other educational programs. And we will instrument them in a way that we can actually study the research or do some research on the impact that those tools are having. And when we think about impact of tools like this, we think about it in a couple of different areas. So kind of the obvious one being student learning outcomes and performance, right? And then maybe less obvious ones being things like measuring the student's self-efficacy and whether what impacts, if any, we may have on their self-efficacy, and also looking at their attitudes towards the subject matter and whether we've been able to create more positive attitudes on the subject and kind of desire to continue pursuing that subject relative to not using the tool. Okay, so that's a bit about our process. This is just a screenshot of one of the tools that we had built. It's called Atlas, which is has gone through a couple of pilots, and we're working towards a broader rollout at Duke within a couple of months, which is sort of a chatbot-like system that helps students navigate classes as part of the registration process. And so we've partnered with our university registrar And we have built a system which uses AI connected to a database of more or less all of the course information we have available to us at Duke. And we can help students identify things like different classes offered in a particular area that they'd like to learn about, compare one class against another class, for example, dive in on sort of what a specific class might cover, et cetera. So this has been well received by students who have been early users of it, and we're continuing to work with our central Duke IT organization to expand the rollout of this for students across Duke. So now get into Qubit, which is kind of the main thing I wanted to talk about today. Qubit is a project that our tagline teaching assistant in your code editor. So it's really a tool for students generally in introductory level programming courses to help them through the process of learning to code, which is a notoriously challenging process for many people. A little bit about the kind of as background, the problem that we set out to solve. So this this particular project is one that I had actually kickstarted with our lab out of my own experience, and many of you have probably had kind of similar experiences teaching classes involving any sort of programming. Kind of in the days when ChatGPT came out, all of a sudden students had access to things like ChatGPT, GitHub CoPilot, et cetera, that were really helping students kind of skip right over the actual learning part of coding and get right to the answer. These are tools that can be incredibly useful for professional developers, and I myself use them all the time in my personal software development, but really were not at all designed for learning purposes. And so something like GitHub Copilot, for anybody that isn't as familiar with what that does. So if you are writing some code and you have sort of a prompt of what you're supposed to do, and you're trying to write a function to accomplish that, if Copilot, and Copilot is sort of looking at your code as you're writing it, and if it's able to determine what it is that you're trying to do, it will just do it for you, and it will give you sort of, it's like autocomplete, sort of a very advanced autocomplete where it will kind of write the entire function often just for you. And all you have to do is hit tab, and there it is. And now you can submit your assignment. And so this caused all sorts of problems when these tools became available to students, of students just sort of blindly using these things. And they really didn't do anything at all to help with learning by the students because that really wasn't the design intention of these kinds of tools. Some other problems with these tools, a second big one is that student use of this tool is sort of completely disconnected from the class and sort of separate from any oversight by the instructor. So we don't know if the students are using these tools, what tools are they using, what are they doing with them, are they trying to use them to help learn, or are they just simply getting right to the answer and submitting it? We have no insight into any of that. And because we can't see what's happening, we have no opportunity to provide correction or attempt to provide some remediation if there's a particular thing that a student may be struggling with, for example. We don't have any good way to know about that and then provide remediation. And in fact, it's actually a bit of the opposite because these tools now exist. At least what we've seen at Duke is that less and less students are going to office hours. They're not coming to TAs anymore. They're not posting on the online discussion board. They're not going to the instructor office hours. They're just going right to an AI tool and sort of getting the help that way. So it's really changing the dynamic of the learning process and what the instructor's role is as part of that process, because they now have access to these sort of separate tools which can provide help. One answer is just kind of banning the tools, and certainly some people have taken that approach, but there are some drawbacks of that approach as well. One is that these tools potentially do have some learning benefits, which we might be able to get out of them when used the right way. And then number two, they are prevalent in industry. So, when a student leaves our doors at Duke and, starts day one of his or her job, they're going to be expected to be proficient in using these things, to know how to use them, to have integrated them into their workflow when they're coding, et cetera. And so if we're not allowing them to ever use these at Duke, as part of the educational experience, then that's something that they're going to be behind the curve and have to kind of learn on the job as they go and change their workflow. We also want to consider sort of what they're going to be going into as they go into industry as well. So this was kind of the problem or maybe set of problems that we faced from the instructor side. It turns out as we went through our stakeholder interviews that there were some problems that we uncovered on the student side as well around getting help when coding. And these were kind of the two main things that our students uncovered through their interviews with fellow students. One is that students often struggled to formulate the question to ask around coding. They didn't know how to phrase it or to say it in a way that they would get an answer that would actually be helpful to them, whether it was kind of asking the question in class or trying to go to the instructor during office hours to kind of get help. They found it sort of stressful and challenging to sort of even figure out the question to ask to get appropriate help. And then the second problem from the student point of view was a problem of getting the right explanation. So there are things like Stack Overflow, Google, even ChatGPT. They would often sort of find related explanations to related questions, but not necessarily something that directly answered their question at a level of understanding that was sort of right for them. Either it might be kind of too simplistic, or it might be too advanced that just went right over their head and they weren't able to follow it. So they, despite all the sort of the different options available online to get answers to questions, they did find it challenging to kind of get the right explanations to what they were looking for. So we set out to kind of build a kind of our own coding assistant, and the objective would be to try to build an assistant that was optimized for learning rather than for productivity. So this would not really be, could be, but not really designed to be useful for somebody who is working as a professional software developer, but more for somebody who is still in the learning process. Arguably, maybe a junior engineer or somebody who's learning a new programming language could find it useful. But we were trying to optimize for learning rather than for productivity enhancement. Secondly, we wanted to make the entire experience of using the coding assistant as seamless as possible for learners. One of the things that students really liked about GitHub CoPilot, for example, is that it was integrated right into their VS Code, which the majority of them use for as their IDE for coding. And so they didn't have to like go to a separate website, or didn't have to kind of use this browser-based programming environment or something like that to get the help. It was kind of right there where they're already used to doing their work. And so in order to encourage students to actually use our tool versus use one of the commercial tools that's out there, we had to make an equally seamless experience so that there wasn't extra burden on the student for trying to use it. Number three, we wanted it integrated into the course experience rather than being something that was completely separate, like Copilot or ChatGPT, where it's not at all tied into the course. The instructor doesn't really know what's going on with it. But we wanted to bring it in as part of the course experience and have it sort of sit in between the student and the instructor, so that obviously the student could see and engage with it, but the instructor would get some valuable insight from it as well, at least at an aggregate level, of seeing, for example, if there were certain questions or certain topics that students were struggling with. So the instructor could get some useful insights in order to inform his or her teaching. If there are like a particular part of a homework assignment, for example, that almost all the students were asking Qubit about, the instructor would be able to then see that and maybe spend some extra time in class the following week going through that together or something like that. So the ability to have insight into the types of questions that students are asking, even at like 3 in the morning, when they're trying to complete their assignment, is really valuable for instructors and gives us useful information to help us adapt our teaching and information we really have not had before. So those were kind of the design principles of our project from the beginning. This was the result of the project, resulted in a tool called Qubit, which is a VS Code extension. So for those of you that use VS Code, it's actually published through I think they call it the Extensions Marketplace. You can find it. It's currently available only with Duke login, so you won't be able to access it unless you're with Duke today. But it is an extension. You just get it right through VS Code. You install it. And after it's installed, it exists as sort of a sidebar in your VS Code. It has access to your code. So as you're working on a problem like this, it sees what you're doing, and then you're able to ask it questions where it can look at your code and try to point you in the right direction. As mentioned earlier, it's really optimized for learning versus efficiency. And so we've designed it Socratically so that if you ask it a question, rather than just kind of giving you the answer or writing the code for you, it will try to ask you questions back or engage in sort of a back and forth with you to kind of get you on the right track. So that was one of the key kind of design elements. The second one was that if the learner was already on a track that would eventually kind of get them towards the answer or get them to the answer, we didn't want the coding assistant to kind of force them to completely change direction. We wanted to try to help the student continue down that track rather than pushing the student a different way to say, no, that's not good. You should actually do it like this. Think about it like this. So we wanted to kind of follow the lead of the student and not try to take the lead itself and push the student down a certain avenue. Because often in coding, there are a lot of different ways to get to an answer. Let's see. So that's how Qubit works. As you're working on the assignment, it sees what you're doing. It can get context to understand what you're trying to do, either through what's in the scripts itself, any code comments, any existing code, doc strings, or you can also upload like a document with context. So if you have a problem set that you're working on for class, you can just upload like the PDF of the problem set, and Qubit will then have the questions to understand the context of what you're trying to do. That's the alternative method. It works for generally any common language. So we've tested it. It's primarily used with Python, but we've tested a little bit with other languages, probably C++ being the other major one that we've used it with. And as I mentioned, it's really designed to kind of work back and forth with the student as sort of a companion. So it won't kind of skip right to the answer. It won't just blindly respond with an answer, but it'll sort of go back and forth and prod the student in the right direction. There's a few other things you can do with it. So you can ask it to, for example, check your code. So it'll look at your code. It'll try to generate test cases to test your code and then run those test cases and try to flag any errors with the test cases. It has what's called a code toolbox, which is sort of like a syntax lookup. So it'll look at what you're trying to do or what the problem is, and then it will try to give you kind of like a little cheat sheet of sort of relevant code syntax if you're working with some libraries like pandas or something like matplotlib. It'll kind of give you some useful syntax so that you don't have to kind of go consult the docs or kind of remember it all yourself. So you can kind of quickly look up syntax as well. Let's see, it is throttled. We do throttle the usage of it for two reasons. One, to manage our own costs, and two, to kind of a little bit sort of limit the usage by students. And so there's a sort of this energy bar, and students can ask it a number of questions, and each question sort of uses a little bit of energy. And when it runs out, it refreshes after 30 minutes. So it forces you to kind of wait a little bit before you restart. That's something we're kind of playing with to figure out kind of the right amount of usage to allow. It also has different kind of setting options, different levels, realizing that people who may be using this may will have a variety of kind of different levels of coding background. Some may be just writing their first hello world, couple of lines of code, and others, like some of our grad students, maybe have worked as software engineers for several years, and maybe they used a different language and now they're kind of learning Python for the first time or something, and so they want to use it, but they kind of know the basics of programming. And so you can change the level, and the level controls sort of how hands-on it is with you. So you can set it kind of all the way on the left would be just starting out. It will keep things kind of very simple, very, very straightforward, not kind of use a lot of heavy jargon, be kind of very hands-on with you in terms of its engagement. And then all the way on the right will be the opposite, will be kind of as hands-off as possible. So give you kind of like the minimum possible guidance or hints that you might need. So you can self-select the setting that you want, and the idea being that you can also change it. So as you go through a course and you feel more comfortable, you can adjust the setting on there. So that is a quick introduction to the tool, a little bit about sort of what we're doing with the tool. We built the tool. The first version of it was completed sort of early summer of 2024, and we've run a few different pilot programs with the tool so far. So our first pilot was over the summer. We ran a coding camp designed for high school students, and so we had 63 high school students from across the state of North Carolina. Heavy emphasis on our local public schools in the area. All of them were beginning programmers, so really just kind of starting out, writing their first Python. And we ran the camp as sort of a bit of a randomized control trial, where we actually ran two different versions of the camp in parallel. We randomly split the students into one or the other cohort of the camp. One cohort of the camp, it was a 3-week camp, and so one cohort went through the camp without using Qubit as part of the camp. The other cohort, Qubit was integrated into the camp, and so they were given access to it, were trained to use it, used it as part of like the small group working sessions they had every day, used it on their own working time, on their exercises, et cetera. And so that camp and our sort of our research focus and looking at that camp was really more focused on understanding any impacts to attitude towards coding and their own self-efficacy versus looking at any performance-related enhancements that may or may not come from using Qubit. We decided to run that because we want to look at sort of the impact of a tool like this on the entire spectrum of learners. One of the challenges we have of doing any kind of educational research here at Duke is that we have a very small cross section of the total population of learners. For example, of people learning to code. We have a kind of a very small and largely homogeneous group here at Duke, and so we wanted to get the tool in the hands of a different cross section of learners, and so that was part of the rationale for running the coding camp over the summer as a pilot. And then we also have run a couple of pilots and courses this past fall. We ran one was roughly 100 student graduate level introductory coding camp that was taught in both C++ and Python in one of our master's programs. And then the second one was another master's course that was actually one I teach which is an introductory machine learning course that had about 40 students, all of whom did have some prior programming experience. So really were not true beginners at this point. But we're using Qubit kind of in a more advanced setting for doing some more advanced things in data science and machine learning. Part of the focus of the efforts this fall have been to look better understand positive or negative impacts of the use of this kind of a tool on performance. And so with the FinTech graduate course, for example, we had students self-select into one of three groups, either not using any AI tools, using kind of their own tool of preference, GitHub CoPilot, ChatGPT, et cetera, or using Qubit. And so we looked at, and so they were allowed to use whatever of the three they wanted for the all of the assignments during the class. And then there was a set of three summative exams during the course of the class. And for those exams, no AI tools were allowed to be used. And so we're looking at the to better understand sort of any notable differences between the different groups in terms of their performance on the summative exams. Okay, a little bit, I'll show you a few insights into some of the things we learned over the course of the summer camp. And I will say that this data is, we've not done the full formal analysis of the data yet. So everything I'm showing you is still from the very preliminary quick analysis that was done, and is certainly will change by the time we go through the final full analysis of the data. But I think it's kind of interesting, at least directionally, to see what happened. During the summer camp, we had 32. So again, half of the students were using Qubit, half were not. The students averaged about 30 questions per student per week, which is actually quite a bit higher than we anticipated. So there were usually 8 to 10 exercises per week that the students had to do. And so you can see that on average, they were asking multiple questions per exercise that they were working on over the course of the week. To date, as of kind of towards somewhere near the end of last semester, we had over 6,000 questions that had been asked of Qubit between the summer camp and the students in the fall classes that were working with it. A few of the kind of notable things from the usage data and also from all of the interviews and surveys that we did with students who have been using the tool. One, they really appreciated the ability to go back and forth because it sort of sat right there as they were coding, and they could kind of very quickly, ask a question, have a follow-up, ask another question, go back and forth with it kind of iteratively. They really like that kind of very quick turn kind of conversational style of help versus what they might get from like going on Stack Overflow or something. You have to kind of search and you get kind of a single answer, but then there's not really an ability to kind of go back and forth or follow up on it. We also early on we had some challenges with the tool kind of giving too much information where it wouldn't directly solve the specific problem the student was working on, but it might give kind of an example which is actually kind of identical to the problem the student was working on. And so we had to make some refinements as we went to try to prevent that type of behavior, to try to keep it from being too helpful and sort of giving away too much information. A few of the insights, again, from some of the very preliminary data that we collected from the summer. This is kind of interesting. So this was from a post-camp survey we did. This question asked about their assessment of the difficulty level of the camp. And as you might expect, you can see that the half of the students who were using Qubit as part of the camp experience rated the camp at a lower difficulty level than the students who were not using Qubit, which maybe is an unsurprising result, but kind of stark how notable the differences in that. Some more interesting things. So we did both a beginning of camp survey and an end of camp survey, and we asked a set of identical questions in each one on their things like their perception on programming as sort of a field they might like to continue studying, a possible career field, their evaluation of their own coding abilities, their assessment of how much they like programming, et cetera. These are some of the questions that we asked, and you can see some of the differences in attitude between the responses of the students who were using Qubit and the students who were not using Qubit were here in the red. So certainly a notable difference in their perception on coding and their attitude towards coding between the with Qubit cohort and the without cohort. Also interesting was looking at kind of the delta from perceptions at the start of the camp to the end of the camp. So how did it change over the course of the camp? If we look at things like I like programming, for example, you can see that overall, even with the cohort not using Qubit, we were able to make a positive improvement on their answer to the statement I like programming. But the group with Qubit, it was more pronounced than the group without. And that goes for some of the other things in here too. Another interesting one would be like the statement, I believe I am good at programming. And so they were rated, it was kind of a Likert scale of agree, disagree. And you can see again here, it's a more positive impact on the group with Qubit. So very interesting results and encouraging in terms of the impact that the use of Qubit had on their own attitudes towards the subject matter and towards their own abilities using it versus the folks that did not use it. So again, that all of that will likely change slightly as we kind of finalize the full analysis of the data we collected, and we anticipate kind of publishing the everything we've learned at some point in the near future. But that was all I had prepared for today. Hopefully that was interesting to you all. And I think we have a little bit of time for questions if there are any.
Thanks. Thanks very much. That was really, really interesting, John. So I would like to ask a question. Actually, just a very short one. Do they use CoPilot at the same time? Or something like CoPilot at the same time?
Yeah, we strongly discouraged use of anything else in the summer camp or also in my in my class in the fall, it was either Qubit or nothing according to the course policy. Now, of course, you can never be 100% sure. We don't know what students are doing outside of what we can see, but we don't believe if there was any usage of other tools, we believe it was pretty minimal.
And just another question about the approach. You were saying that you didn't tend to try to discourage their general direction. But my experience sometimes with students is that they do have completely the wrong idea. Is that something you look at that, sometimes, of course, there are multiple ways to do it and their way may work fine, but sometimes the advice of a human would be to change the complete approach. Any thoughts?
Yeah. Yeah, we this is one of the things we've been working on since the launch of Qubit is sort of differentiating the response of Qubit based on where we believe the student is going wrong. So when you're coding, there are errors of logic and errors of syntax. So if we identify it to be an error of logic, the student is attempting to go down a path which is not going to get them to where they want to be. We will try to switch them onto an alternative path or get them to kind of take a few steps back and sort of rethink the start of the process. If it's more of an error of syntax that they are kind of going down a path but sort of aren't quite sure how to formulate it or the right syntax to use or that kind of thing, we will try to keep the student on that path and try to guide them through kind of formulating the code around their approach, as long as we determine their approach is one that would ultimately get them to the answer. Yeah, good question. Yeah, and it's not an easy. It's very much something that we're still working on. I would say it's not necessarily an easy thing to do. It's not always easy for human TAs to do that either, and certainly for AI models. So we've gotten better, but it's something we're still working on.
Thanks. Matthew.
Yeah, very interesting, John. Thanks for this. So you were saying that you sort of crafted it to have the Socratic response. in an attempt to try and guide the students that way. Was there specific training of the model that was required to do that? You know, you have to provide it with what you believe are the Socratic responses so it can learn what an appropriate Socratic response is. And could you talk a little bit about that?
Yeah, so we that is also an area that we're continuing to work on. Our early efforts for doing this have been based on what's called few-shot learning, meaning we provided sort of lengthy prompts with several examples of sort of the behavior that we would like the model to use, and the examples and sort of guidance on behavior differ a bit depending on sort of the type of error that we're perceiving that happens to be taking place. And so that we have stuck with that approach through the summer camp and through the fall course, and we've refined that approach to be working better than, for example, the start of the summer camp. The next kind of logical step in terms of further improving its ability to do that is likely to fine tune our own model to the type of behavior that we would like it to use. And so we're looking at doing that now. That's a bit more of a complex thing, particularly to kind of curate kind of the right set of data to use. The fine tuning process itself is not that bad. It's really more of sort of getting a data set that's appropriate and trying to figure out how to do that. And so that's something that we're working through right now, trying to put that together.
Good. Yeah, I mean, that's what I was thinking, that it's actually the training set or the fine-tuning set to you want to have enough breadth of variety in what you're going to be training on so that it just doesn't always look like the same. But
yeah, exactly. And you
work.
want it to be, and you want it to be coming from folks that either are highly experienced TAs or instructors who have been doing it for a while. They kind of know how to guide students and create kind of a gold standard set of data to use to train it. Because if you train it on like somebody who's never been a TA before and sort of just kind of puts together answers to questions, it's not going to lead to the kind of behavior that we want the model to use.
Yeah, good. Thanks.
Sure.
Other questions? Go for it. Dylan.
Dylan, yep.
Hi, yeah, thanks. This is super interesting. My question is sort of maybe a much more speculative one, which is just like, if you wanted to do this for something that was not programming, do you think it would be possible, or do you think this is sort of possible in some sense right now only because there's so much very useful examples of coding and that these things can already do sort of coding health fairly well already?
Yeah, good question. I think it's certainly much easier in programming. I think there are some other disciplines where that could be logical extensions. Math would be another one that could probably would be very logical. Possibly some areas of science, and then there are other areas that are quite a bit different. So yeah, I think that we're working with a few other faculty members that have interest, particularly in some areas of the sciences at Duke and similar types of systems to kind of help students navigate through problem solving. And those will present kind of different challenges. And I think there are going to be, I think coding is probably the easiest one of everything, at least at this point. So those will be more challenging. But I think I mean, if we learned anything over the last couple of years, it's that nothing is, should be considered impossible. So I think that with time and work, I think it will be possible to create something that could be useful in those areas too.
Okay, yeah, that makes a lot of sense. Thanks.
Sure.
More questions. So is there plans to make it more accessible outside Duke? I think.
Yeah, we hope to. It's likely that we will open source the code for Qubit so that if other universities want to pick it up and use it, they would be able to. We are also excited about the possibilities of it at other levels, particularly like the high school level, maybe even adult learning. And in those cases, it may be unlikely like a high school, CS teacher is going to kind of pick it up open source and set it up for all their class to use. And so we're trying to figure out the best model to enable folks like them to be able to use it. And so we're working with some folks at Duke to try to figure that out right now. It's not totally obvious at the moment, but it is certainly the intention to try to make it available as broadly as we can.
Hey, any other questions for John? All right, if not, then thanks again, John. That was really, really interesting. I really appreciate it.
Sure thing, my pleasure. Thanks everybody for joining. Have a good afternoon.
Thanks, John.
Thanks,
Yeah.
everyone.